Hello, great people. I hope you are doing well. Welcome back to part 5 of our revision of the higher paper 2 AQA GCSE maths. Boom, got it. So we've got question 21. 3 items were bought at a car boot sale. We've got item A, item B, and item C. The question then says the density of gold is approximately 19 grams per centimeter cubed. Which item or items cannot be gold? You must show you must show your working. Well, the units kind of give us an indication as to what density is. So grams, that's measuring mass. The per is divide, and the centimeters cubed is a measurement of volume. So that is equal to density. Okay, so with the first one, item A, we see that the density is equal to mass, which is 9.5 over volume, so 9.5 over 2. And what is that going to be? That's going to be like 4.75. Okay, so 9.5 grams divided by 2 centimeters cubed, that's 4.75 grams per centimeter cubed. So we can already see that this one cannot be, because it's nowhere near 19. Let's look at the next one, item B. Let's do that in a different color, actually. We've got the mass, which is 57. Okay, and then over the volume, so 3. So that's 57 grams over 3 centimeters cubed. 57 divided by 3 is equal to 19. So that's 19 grams per centimeter cubed. So that's good. This one could be gold. Imagine buying gold at a boot sale. Hey, wow, fortunate. And then lastly, we've got item C, where density is equal to mass, which is 76, over volume, which is 4, so 76 grams over 4 centimeters cubed. And that is, again, equal to 19 grams per centimeters cubed. So again, this one could also be gold. Imagine possibly B and C were gold. And then, yeah, A is the one that cannot be. It's not close. Not close to 19 grams per cm cubed. Whereas these ones are close. This one's close, and this one is close. And this all counts as working, guys. This all counts as working. It doesn't have to be this essay where you're using nevertheless, because, but, notwithstanding, hitherto. You don't need any of that. Just a simple, clear explanation. Next question. We have 2 solids, J and K, have the same density. The same density. So again, we know density is equal to mass over volume. So it says complete the table and include the units. So if the mass is 8 and the volume, if the mass is 48 grams and the volume is 8 centimeters cubed, the density is going to be mass over volume. So that's going to be 6. And our units is, of course, going to be, so that's grams, that's centimeters cubed. So that's 6 grams per centimeter cubed. So that's going to be 6, and then grams per centimeter cubed. Okay. That means that because now we know that J and K have the same density, we know that for K, that's also going to be 6 grams per centimeters cubed. And if we want to rearrange this formula, we multiply both sides by V, we get D times V equals M, and then divide by D, we get V is equal to M over D. So volume is mass divided by density. Okay, so with this one, we have 78 divided by 6. 78 grams divided by 6 grams per centimeters cubed. And then 78 divided by 6, well, that is going to be 13. And that's going to be 13 centimeters cubed. Okay, that's the table filled out. Next, A is the point 2 minus 5, B is the point 4 minus 9. Show that the gradient of the straight line passing through AB is minus 2. Let's just draw a little diagram. It doesn't have to be an amazing diagram, it's just a rough diagram. So I like to draw just roughly where the points would be. So we've got 2 minus 5, which is approximately, so that's like 2, and that's like minus 5, so somewhere around here. Okay, and then 4 minus 9, well, 4 is bigger than 2, so we go to the right. Minus 9 is smaller than minus 5, so we go a bit down. So like that. So we've got there 4 minus 9, and then we draw a straight line. Okay, then we have the gradient is equal to the change in y. That triangle is delta, that means change in y divided by the change in x. So if we look at the change in y, well, it's going from minus 5 down to minus 9. So that change in y is minus 4. And then the change in x, well, that's going from 2 to 4. So that's going to be 2. And that equals minus 2. That's it. That's good enough for an explanation. The gradient passing through the straight line, the gradient of the straight line passing through A and B is minus 2. We're good. Next, we've got C is the point minus 301, 601. Does C lie on the straight line passing through AB? Okay, well, if it's all a straight line, then what should happen is that the gradient between any of these 2 points and C should also be minus 2. Okay, so we know the gradient between 2 minus 5, and 4 minus 9 is minus 2. So to check that it lies in a straight line, let's find the gradient between 2 minus 5 and minus 301, 601. So again, I'm going to draw a rough-ish sketch just so that you can see what it's looking like. So the point being, you've got 2 minus 5. It's approximate. Minus 301 is to the left, 601 is up. So again, this is not drawn to scale. Minus 301, 601. Then you've got back. And then we've got this and this. So we know the gradient should be the change in y over the change in x. So the change in y, oh, that is not a good color. Wow. What was I thinking? Change in y over the change in x. So the change in y, we can see it goes from 601 to minus 5. So that change there is 606, but it's negative. So negative 606. And from minus 301 to 2, well, that is an increase by 303. So that's going to be minus 606 divided by 303. And that gives us minus 2. So, yes. Okay. So, first of all, you could have used, I used 2 minus 5. You also could have used 4 minus 9. And what should happen is when you do the work, you should get the same gradient. So I challenge you to maybe try the gradient between 4 minus 9 and minus 301, 601, and you should get the same answer. Okay, let's keep it moving. The diagram shows a lawn with a fence along one edge. Right. So we've got this. 1 can of weed killer covers 90 square meters. Each can costs £19.25. Work out the total cost of cans of weed killer needed to cover the lawn. Okay, so first of all, we need to work out the area. We can see here that we need to work out the area of this shape. So the area of the trapezium, half the sum of the parallel sides times the height between them. That is how you find the area of a trapezium. So you've got this 12 plus 20, those are the parallel sides, half the sum, times the height between them. The height is the fence, not to be confused with the 17. When you measure height, you don't measure it slanted, you measure it going straight up or perpendicular to the horizontal. That's going to be times fence. I'm just going to put fence here. Okay. And then how to work out this fence? Well, what about if I did something like this? If I just made the length here, this red line still represents the length of the fence, and I make a little triangle. What's this length going to be here? Well, if I know the entire length along the bottom is 20, and this length along the top is 12, that means this is going to have to be 8. So I've now got a right angle triangle, and I can use Pythagoras Theorem to work out what the length of this red line is going to be. So let's just call this, well, it's actually the length of the fence. So the length of the fence squared plus 8 squared is equal to 17 squared. Using a squared plus b squared equals c squared. And then I'm going to rearrange it because I'm working out a shorter side, I'm subtracting. So my fence squared is equal to 17 squared, take away 8 squared. Okay, then I'm just getting out a calculator to work out what this is. So 17 squared is 289. And then I'm taking away 8 squared, which is 64. So that's 225. So the fence squared equals 225. Therefore, square rooting now equals the square root of 225, which equals 15. Okay, so now I know that my length or my height is 15. I can now work out the area. Okay, so I can take this information and work out the area. So, I should probably keep everything that I have. So I have 12 plus 20, all divided by 2, multiplied by 15. Okay, and then just using my calculator, because I can put this straight into my calculator, I've got that gives me 240. So my total area is equal to 240 meters squared. Okay, then I know that 1 can of weed killer covers 90 square meters. So how many 90s go into 240? Well, 90 plus another 90, well, that's going to give me 180, but that's not going to cover all of it, so I have to buy an extra can. So plus 90. It does go to 270, but if I buy 2 cans, that's not enough. Okay, so that's 90 meters squared, 90 meters squared, 90 meters squared, gives me 270 meters squared. I'm going to have the extra, but I have to buy 3 because 2 isn't enough. Okay, so I need 3 cans, and we know that each one costs £19.25. So I've got £19.25 multiplied by 3. So 1925 times 3 gives me 57.75. Okay, so there we go. That is the amount that I'd be spending, 57.75. Don't know, is that a lot to spend for weed killer? Who knows? Okay, next question. E is the center of rectangle ABCD. Work out the length of DE. Okay, what's going on here? Right, so let's fill in stuff that we know. So I can see that this is also going to be 20 centimeters. E is the center, which means that if this height d to a is 12, then from here to here, that's going to be halfway. So that's going to be 6. That's already useful. Oh, look at that. If the whole length is 20 along the top and E is the center, that means going from here to here, that's just going to be halfway. So that's going to be 10. So I'll just draw this triangle here. I've got a triangle like this, where this length here is 10 and this is 6. And I can use that to work out this length here. So I've got 6 squared plus 10 squared equals c squared, using Pythagoras' theorem because I've made a right angle triangle. So then that gives us, well, we've got, what is that? 136 is equal to c squared. So c is equal to the square root of 136. Or, in other words, that's dE. Okay, so dE is the square root of 136. I think that should be okay as an answer, but just because it's a calculator paper, if people want to see decimal answers, I will also provide a decimal equivalent. So square root of 136, or 11.662, correct the 3 decimal places. I prefer the exact answer, but there we go. That's how it goes sometimes. That is it for this video, guys. I hope you enjoyed. I hope you found it useful. And stay tuned for the next one. Take care.